Sometimes you need to hide unfinished prompt templates from your MCP server while keeping them in your codebase for development. We'll see how FastMCP's enabled equals false decorator argument lets you disable prompts completely, making them invisible to clients while preserving the code for future use. This pattern is perfect for experimental features or seasonal prompts that shouldn't appear in production yet. At MCP, prompt enabled equals false. Def experimental prompt. This prompt is not ready for use. Return. This is an experimental prompt. This demonstrates the decorator-based prompt registry pattern, where Python functions become reusable LLM message templates through declarative metadata. The key concept is treating prompts as first-class components that are discoverable, versionable, and composable, rather than hard-coded strings scattered through your application. What makes this distinctive is the dual nature of prompts. They're executable Python functions during development, but become structured templates for LLMs at runtime. The pattern works by leveraging Python's decorator system to create a bridge between human-readable code and machine-consumable schemas. When you decorate a function with @MCP prompt, the framework captures the function's signature, docstring, and return type to generate a complete prompt definition, including parameter validation and type conversion, without requiring manual schema writing. This creates a clean separation where your prompt logic stays pure Python, while the framework handles serialization, transport, and LLM integration automatically. This approach solves the problem of prompt fragmentation and maintenance in LLM applications. Instead of managing prompts as loose strings or external files, you get version-controlled, IDE-friendly code with full type checking and auto-completion. The trade-off is a slight learning curve around the Decorator API, but the payoff comes in maintainability. Prompts become reusable across projects, can be dynamically enabled or disabled, and support async operations for data fetching. It's particularly valuable in production systems where prompt consistency and discoverability matter more than one-off experiments. Let's break it down line by line. At MCP, prompt enabled equals false. Def experimental prompt. This prompt is not ready for use. This disables the prompt using the @MCP prompt decorator with enabled equals false. The decorator pattern cleanly marks experimental or incomplete prompts, preventing accidental exposure while keeping the codebase organized. The docstring serves as both documentation and a clear signal to other developers that this isn't production ready. Return. This is an experimental prompt. This returns a placeholder string indicating the prompt is experimental. The disabled decorator prevents this from being exposed to users while keeping the code available for development. Prompt disabling pattern. The @MCP prompt enabled equals false. Decorator creates a dormant function that remains in your codebase but is invisible to MCP clients, allowing for gradual feature rollouts or experimental development without deployment. Disabling a prompt doesn't remove it from Python execution, only from the MCP protocol's available prompt list. This technique maintains code consistency while controlling client exposure.
The prompt that disappears from the client still answers every call.